So, my name is Denis. I'm Google Developer Expert Android, IoT and Pay. Fun fact about me, I have 100 episodes, more than 100 episodes about Android and Android Dev podcast. But right after I moved to the United States a year ago, I figured out like what most of people can stand the podcast because it's in Russian. But we're improving and making it better, and there's more episodes happening in English, so you can find it in iTunes or somewhere else. I'm also passionate about everything new that's happening around Android, and Flutter is the one thing that I'm pretty curious and following since it was launched in the super early alpha version. The preview, it was presented like 3 years or 4 years ago for GDs, and we were so impressed by that. And now I'm like playing with that, making some basic apps at my home, and my friends working in production with Flutter, so I have more insights about how it's going in prod. So let's talk about that. What is actually Flutter? I'd say if you from different worlds, not related, super related to mobile development, it's SDK that doing high performance as developers and the team saying about the Flutter, and it really works on both on Android and iOS. It's even web in preview. We can talk about that a little bit more later. And the cool part about that, it's open source and developed by Google. Let's look at it from an Android point of view and what developers with Android background like from that. First of all, the build time on Android is awful. If you want to build some huge app, it's taking so much time, and even small changes are not applied. There is some kind of code reload, and each time they promise to make it better, but trust me, it's not working. On the Flutter, it's better. There's a situation when there's two concepts of the Flutter. The one is interpreted and runs on a debug mode on the device, and it's JavaScript. It's basically Dart compiles to JavaScript, and JavaScript runs in the virtual machine of Chrome V8 on the device, and it's run smoothly, and it can hot reload anytime, anything, any changes. And the state will stay remaining. Everything that was not changed by code changes, it stays. So even like navigation or some parts of the screen. So this is the famous GIF from every Flutter presentation that's showing like if you change some value and the change text of this value and click hot reload, it will be uploaded to device, and the rest of the string will be stay remaining. Why it's happening like that? What's the difference? So there's a lot of different cross-platform or native frameworks, and we can see the difference. So for Android and iOS SDKs, there is a different architectures called like MVVM, MVC, and it's compiled to native. And this is a good performance, and it's working as expected because it's native. There's also different JavaScript-like interpreted frameworks. Maybe you've heard about Titanium, Cordova, PhoneGap, Ionic, a lot of them, super old. Not sure they're still alive. And the new one is more famous. It's by Facebook, React Native. And if you start thinking about Flutter, the competitor on the field is React Native. But the difference between React Native and Flutter is that Flutter is compiled to native. So let's compare them. On Flutter, it's compiled to native, and React Native is interpreted. And the difference between that, the Flutter is high performance in production, React Native in production and development mode is kind of average performance. Debug mode for Flutter is also average performance because, as I said, it's JavaScript that runs on a V8. But when you click compile to production, it's gonna compile to C++, or it's actually compiles to the machine code, and it's run natively and super performant. That's why, with their own graphic engine. And there's difference of the vision, how the developers and the community around building. The Flutter is community first, and React Native is primarily internal, and sometimes Facebook making it for their own needs and do not satisfy some issues on the GitHub or some requirements by other teams. But Flutter is always listening to you and listening to other developers, and that's cool. And it's not just like some marketing bullshit. No, that's from my personal experience that I've heard from other people, and this is really impressive that they, same as Android, they always hear a community. That's why we all hear the GDG, GD, all these events, DevFest. because Google cares a lot about community and helping them to achieve their goals with their great products. So, great looking widgets and fast widgets. Why? Because they compile to native, as I said. You cannot do any 3D graphic, obviously, because there's no special engine, and you can go to Unity or somewhere else if you need that. But for 2D and some basic animations in your app, and like even advanced transitions in the screens, it's great. It's way much better than native Android. Let's talk about runtime. So as I said, there's two differences between debug and release. In debug, it's just-in-time compilation, and it's low frame rate, app can be larger, and there's a hot reload. You can push the changes immediately to the app. On release, there's no hot reload, but the weight of the app is way much smaller, and it's a high frame rate. How it's working? Where it compiles? On Android, it compiles to NDK, it's ARM or x86 libraries, and to that, obviously, final result, final artifact is APK. For iOS, it's LLVM and ARM library and IPA file. You may wonder, what if I need some SDK like Camera SDK or some Apple Pay SDK, for example, or any other platform-specific SDKs? How can I touch the code? Yeah, there's a meta channels. There's a way to communicate from Flutter client to some native code. So obviously, if you need some more than just fetching some data from network and showing it to user, and you need some platform-specific stuff, you have to learn iOS and Android. And there's no way like, oh, there's a cross-platform solution. I don't have to learn anything except Dart, because Flutter is powered by Dart language. No, unfortunately, you have to understand how to publish applications on both platforms and knew some basics of Android and iOS to work with that. But anyway, it's very much simpler than just writing two different applications. And there's already in the market million user apps that proven that yes, Flutter is alive and Flutter is ready to be in production. And Chinese markets are huge fans of Flutter. They ship in a lot of Flutter features. The last release from Asian markets, it's a Grab. Do you know what the Grab is? Anyone heard about that? Yeah, thank you. So Grab is it's like Lyft or Uber here, but they growing more because Chinese, there's a trend. They saying we are mega apps and we wanna order tickets for the movie. I don't know, order laundry, transportation tickets. Obviously ride-hailing, everything in a single app. And for that case, Flutter is a great way to prototype and ship it as soon as possible to the users on the both platforms. As I said, it's optimized for performance. It's compiled to native code as we've seen. There's no bridge needed, because for JavaScript, if you call some code, you need the bridge and it's additional overhead. And there's a structural repainting. That means that if pixels on the screen are not changed, on the next frame, it's not going to redraw, and it saves CPU and GPU time. And there's no reliance on OEM widgets. If you're Android developer or ever tried to write Android, you know there is a new version of Android coming to the user phones, and you have to support the new changes that just available on this version of Android platform. Everything related to Flutter widgets compiles exact to your APK, and you don't have to wait till something new released to users and shipped to their phones. You ship everything you need inside your APK or EPI if you talk about iOS. Yeah, it is super powered by Dart or other powered. How many there's Angular developers are familiar with the Dart? Thanks, thanks. So after you writing code on Kotlin or even Java, you might start feeling like, Dart is not as fancy as Kotlin. But anyway, there's a sound type system, there's tree shaking that improves garbage collection with the multi-gen localhost GC, and a lot of libraries available, to be honest. It's called plugins, but there's a lot of them. And as I said, single code base for Android and iOS. Also, the cool part about that, the Flutter team start thinking when they start writing their framework, they start thinking about not just the users, that it's fast and shipped to both platforms, but they also start thinking about, what about tooling? Are we making developers happy to use this framework? And they created great tooling to check performance, to debug your app and understand what's going wrong right now and how to make it better. And after Java, Kotlin, Swift, it's obviously easy to learn Dart. There's nothing super special. We will see in the next slides about that. But things to note, because sometimes people can be surprised about Dart. Dart is a single-threaded language because it's supported on the web, and the web, as we know, is a single thread. If we're not talking about service workers, but there's isolates. You can move your work, serialize your commands to isolate, and move your work to this another thread. So there's a possible to do that. Comparing to, for example, Kotlin, there's no function override, there's no data classes, extensions, no safety, no sealed classes. But first of all, it's already a mature language. There's a second version, and it's strong typed language. And the cool part, it's improving and it's upgrading all the time and growing all together with Flutter. And that's why I think my personal opinion, it's not official vision, but my personal opinion that Google decided to get the Flutter and Dart together because when they started doing Flutter, they figured out, okay, we need to make changes in the language. And what language we have flexibility to change? Obviously Dart, because we sit in nearly the same office, so we can do that. But that's just my guess. Let's talk about tools. There's a Dart observatory, and you can see what's happening with the code, like debug memory leaks and fragmentation, check memory allocation, and see what line of executed. And it's supported by IDE, and you can write code not just in Android Studio. If you don't like Android Studio because it's loaded so long, you can use Visual Studio, and it's working brilliant there. So there's tools. There's a lot of terminal tools, and it's integrated to IDE to, for example, analyze some problems like some linter and formatter. A layout editor. As you may see, there's a small screenshot. It's really hard to see, but if we go on the next slides, we'll see that the difference between layout editing on Android or iOS and Flutter, that the Flutter is everything written in the code. You don't have to edit some layouts in XML. But anyway, there is a visual editor that helps to change these parameters. And there's a difference. So, Imperative, current iOS and Android regular way of declaring layouts, you create class and you set parameters. In a declarative way, you have hierarchy and you change parameters in this DSL-like hierarchical lines. And it's, in most cases, it's sometimes some kind of beta. And Android, there's a new initiative called Compose, created by Google. It's still created by Google. And on iOS, there's Swift UI that's doing the same. So they decide, oh, it's working. And this is like why the React is so popular on web, and that's why React Native is trying to be on the platforms, on the mobile platforms, and also declarative way of editing layouts presented in mobile work with Flutter. So, as I said, there's a channels that let you, meta channels that let you call some platform-specific code, but you also you can use Flutter as just an activity, and you can launch any screen from the native, and you can mix. So you can have some platform-specific. For example, you use R-Core for arguments reality, and you can launch your R-Core on a one activity. User can do something, but you have to. But you want to ship the rest of the part of the app faster, and you can build the rest of that with Flutter, like, I don't know, different markets of your AR stickers or whatever you want to do. As I said, whole layouts is hierarchical, and there's a ability to build this declarative way, and every widget is a mix of different widgets inside and some widgets inside, and this is how it's working, and it's super flexible, and you can write anything you want. Like after like 8 years of Android, I can say yes, that's the way I want to build widgets in the future, and now it's way much better than what we have on Android now. And if you're an Android developer or have some experience with Android, you may ask, is there any familiar libraries that I'm familiar with on Flutter that I can reuse? And the first thing that we use in Android is ArcJava. And there's a Dart built-in streams, and on top of it there's RxDart. So if you're super reactive folk and you like that way, you can use RxDart and feel yourself comfortable with all these streams, flat maps, observables, and symbols. But if you coroutine-like, in Kotlin there's a concept of coroutine. It's like in a C# async await, and in many other languages, obviously. So there's a way to use async await. It's part of the language, no problem with that. For network, you then have to use some third-party libraries we're doing all the time in Android. There's a good package called HTTP, of this name, that built inside the Dart plugins. You can just reuse that. This is how you can make network requests. For JSON, there's two types of JSON libraries. The first one is the Dart convert. You can manually decode and encode JSON, but we know it's boring, so we want to automate that. And there's a JSON serializable, so we can make annotations of our data classes, of our model classes, and it will be parsed automatically from JSON and back to JSON. Obviously, mobile world is following all the trends, and there is a gRPC and GraphQL as the different protocols to communicate via network, not just JSON sending via RESTful APIs. So it's also supported, and there's a plugins to support that. Image loading, yeah, finally no more any third-party libraries. All you do is just image network, and you fetch image, and if you want a cache network, you can call cache network image and put a placeholder, for example, and it will be cached on the device. And the cool part, it will be cached on the both platforms, Android and iOS. Key value storage, as I said, there's a lot of plugins and third-party plugins. For example, my friend from Singapore created shared preferences, if I remember correctly. Yeah, this should be by him. And it just wraps NS user defaults on iOS and shared preference on Android, and helps you to write a single code, but will be used platform-specific storages on both platforms respectively. Database, yep, on Android and iOS there's SQLite, so you can use the wrapper called SQFlite that help you to write SQL if you need. For most cases, my personal opinion, you don't need SQL for mobile applications if you're not writing some super complex with different data objects and super complicated cache that works offline. For most cases, applications just fetching something from network and showing that to users. So not worth to spend so much time with SQL. You're not still an engineer for when you're doing mobile. And there's some ORM wrappers if you're super fancy and you like writing ORM, but my personal opinion is like that. Dependency injection, it's super popular on Android to do dependency injection for beta testing, for better understanding what's happening and how you create a graph of different dependencies and the scopes of them. There's a package inject and a Kiwi and maybe some new libraries that appeared recently, and I missed that. But package inject seems fine, and it's even compile time, so it can check that the graph is consistent even during the build time. Navigation, yeah, you may ask, like, if it's just a single activity and whole screens is just a single activity, how you can switch between screens? So you stay on the same activity, but you can use Navigator to return from one screen to another and provide some navigation methods going back and create and it's helping you with the back stack of your screens. On Android, there is a platform problem. If you rotate your screen, everything gonna be destroyed and created again. And if you not store it on some local cache, you lose that. And there is a platform-specific solution to solve that problem called saved instance state, so you can serialize all your data and store it. And after creation new activity, when you rotate the device, it's going to be restored. But it's not supported on Flutter. But there is a Hugo from Google Developer Experts, and he created native state, and it's helping to work with the state on both platforms. So at least there is a third-party solution and not official support. Maybe because of the web. Because on the web there's not that problem. Architecture approach. There's different architectures you can use, like Hollywood's on the mobile side is huge. People love to talk about different architectures and spend hours discussing what is the best approach. But the first approach that every new engineer starting doing on Flutter is just called vanilla, but it means just everything in a single line. You don't care too much about architecture, you just writing that what comes from your inspiration, from your mind, and don't care too much about architecture. You can use block. It's kind of like MVVM from my point of view, but because Flutter is all about widgets, not the whole screens, so you connect your widgets to the repository and do it in a reactive way. And if you like the web, popular on web, Elm or Redux-like approaches with single directional, unidirectional data flow, there's a Redux-like, and you can do that here too. There's a lot of libraries who's helping you to learn about that and start implementing in your applications. Or you can write it by yourself, because there's nothing super special there. You have to just understand the way what is the Redux about. Cool part about Firebase. So if you're talking about Google supported a lot of Flutter, and Firebase has a lot of different libraries, like what we prefer to use, like real-time database, some cloud functions, advancement, analytic, and crash logger. Obviously we need some crash log, and we can use Firebase crash analytic inside the Flutter is the same way as we're doing on Android or iOS. And the cool part, there's even Firebase ML Vision, so we can reuse those libraries to support some image recognition from the camera or from some user input. So let's summarize. If we talk about Android, it's easy to learn after Android or iOS. There's a fast delivery on several platforms, Android, iOS, and now you can ship it also to web. It's super early preview. It's not working as great as on mobile, especially because not many features of Flutter is supported here, but still, anyway, it's already in development, and you can, at least for like internal testing, launch it on the web too, just with a single button compile. And it's great for performant UI and animations. So my personal point of view, if you're gonna be second Uber or Google Maps, don't go with the Flutter way, because Flutter is not about complex, heavy applications with like 100 developers inside it. Right now it's more for prototyping or for simple applications like fetching some from network, showing to user. Maybe if you're doing some fitness app and you need nice animations that is shown in the previous screenshots, it's a great time to use Flutter because everything working here, and you can call native APIs if you need GPS data. There's a lot of wrappers around GPS for iOS and Android and for camera, so you don't even have to care too much about platform-specific implementation. And the performance is the #1, and the shipping to 2 platforms is the #2 features that is great. And also, when you developing your apps and you can iterate and like hot reload to your phone, to a device or emulator in a seconds, is way much better experience than wait to several minutes when it's shipped to a device and restores everything from starting everything from scratch. So that's what a Flutter is. I hope you learned something new, and thank you for your time. Thank you. Do we have time for questions?
Yeah, we have time for questions if you want to do that.
Perfect.
So anyone? Yeah.
I just started getting into Flutter, and one of the things that I'm trying to figure out is there's the material widgets and Cupertino widgets, and it seems like if you want it to look like the iOS like native widgets, use the Cupertino widgets, but they don't quite like map one-to-one to the material widgets. I'm just wondering if you have any experience with developing like cross-platform Android and iOS, and how you decide like which widget, like when you would use a native like iOS widget versus a material widget and vice versa.
Yeah, it's a great question. So briefly explain for everyone else who's not as great experience with the Flutter. So there's two platform-specific applications, how they look like. If you look at Android applications, you start feeling like, oh, there's how Android application looks like. And if you look at iOS application, you start saying, oh, this is on iOS. There's different physics, different accelerations, different animations, and different widget elements of the screen, and sometimes even different, like bottom bar on iOS or sandwich menu on Android is more popular on Android, or like even on a header, like central title in the center on iOS and title on the left side on Android. And there's some small differences. And there's a two set of widgets, as the question was said. There's a Cupertino for iOS and material for Android. Yeah, and unfortunately, right now there's no single like easy way solution to ship it once. Like you write in one set of the widgets and they look similar on both platforms, or switching to both platforms. And if you wanna do that, you have to write if else. Yeah, that's what it is. But I've heard there's some plans to standardize or help somehow to have a standard way just to quick switching between them. There's some plans, what I've heard.
Yeah, I saw a pattern that somebody linked to on a GitHub that basically like you choose, like for a button you choose like, oh, I want to show this material widget if it's Android and this Cupertino button if it's iOS.
Yeah, unfortunately that's how it is.
It was more, the question was more like technically I think that's possible, but I guess from like an app design perspective, do you always want to show like do users expect the standard iOS widgets for everything, or like would you do all Cupertino widgets for iOS and all material for Android, or like mix them, or?
Yeah, talking about that, what I'm seeing across the industry, most of the big companies like. I'm working at Lyft personally, so at Lyft we have Lyft product languages, and we're trying to help users to see the same experience on Android and iOS with as little as possible differences for some platform-specific differences, right, as I said in the header. But rest of the buttons is the same, rest of the switches is the same, and many other products trying to look the same way as they look on the both platforms, even on the web.
Yeah.
So for most cases, you don't have to care too much about to be super platform specific.
Okay.
And even material design 2.0, what the difference between old material design and new material design, announced Google I/O a year ago. They said now you can, because every app starts looking the same, like material way. Like you say, oh, again, you feel like you sold this same application again with different features inside. But in Material 2.0, there is more branding style to help companies to express their branding and their feelings. So not to look like a platform, but to look like their brand, and that's the most important. Yeah.
Okay. Yeah. Thanks.
Yeah. Any other questions? Right, so thank you so much, and thank you for coming on a Saturday morning. That was not that easy, I'm sure. And thanks organizer for inviting me.
Well, thank you for coming.
Thank you.